Welcome all. You're the third and last group for us this morning, and so I think we figure that we're between you and lunch. So, okay.
You got 1 hour. Good.
Okay. So, thinking about what's going on here is I really don't have any data to present to you today. What I'm here to talk to you about is some work that we're initiating here at Michigan State. And so our station here is the Climate Resilience in Potatoes Station. And so this is some new research that Chris Long and I have initiated along with Yan Suk Dong, our ag engineer, and our climatologists, Sharon Zong and Julie Winkler. It really stems from work a few years ago where we started to ask that question of, as we're seeing weather events occurring during the season, and we're also seeing really a change in how our fall weather conditions. What is how do we manage our crop, and how do we manage our storage crop? And so we did some growth chamber studies a few years ago and put potatoes into storage and tried to understand them, and so that kind of led to this really get out into the field and start doing some actual experiments under field conditions. And so this is our first step at doing this, and we were able to get some seed funding through Michigan State University to start this, and also from the Michigan Department of Agriculture. And so we're quite excited to have this new direction, because we think that we need to really understand how to manage our weather events in the season, which would be heat stress events or maybe water stress events. We really at this point aren't dealing with over watering. We're dealing with underwatering at this point. But that is an issue that's on our minds, but isn't being addressed this summer. And so what we've done is we have two different studies designed here. And so what we have on this side here is we have two varieties being grown. We have Snowden and Mackinac. So an older variety and a newer variety, storage varieties, chip varieties. And what we're trying to do is create 4 heat events during the season, like a week-long. Figure you're growing, the crop's growing, and all of a sudden, the West just sends us a high and really dumps a lot of high night temperatures on us. And what does that do to the crop? So we have an early, like before the crop started bulking, stress, 1 during tuberization, and then 2 after tuberization while the crop is bulking. And so we really have 4 treatments going on there of of stress events occurring on the crop. And so then the idea is to look at the production results we get from these heat stress events, but then take those potatoes and put them in the storage here and monitor their chip quality, their sugars, and compare that to when we have, our normal conditions of the season, okay? And so this is going to give us some insights, like is there really certain stress points that make the most difference, or is there different stresses, time points during the season that end up with different results in the storage? So we're really in this learning phase. But I'm putting my money on tuberization, that the heat stress of tuberization is probably the most critical. And so then, do varieties help us manage this, or can we come up with some management schemes that help us mitigate some of the stress that we see on the crop? We don't have all the answers yet, but it's okay. So that's what this is. So we built this greenhouse. I give kudos to our technical staff of Chris's team and my team to build the greenhouse and the rainout shelter here. And so the conditions that we're putting in the greenhouse is we're running about 100 degrees during the day, building up to that, and then at night keeping it in the high 70s. That's, I consider, pretty stressful on the crop. We're not trying to kill the crop under there. We're just trying to be something that would be a bad time that we would talk about. Okay, and so that's kind of our goal, and we don't have any problem keeping the temperature up in there. Young Sooks actually helped design this so that we can remove heat and not have it spike too high. So it's great having an ag engineer on study. Over here on this side, we have 4 varieties. We have Snowden, Lamoka, Manistee, and Mackinac being tested under a rainout shelter. So this rainout shelter is knocking 50% of the moisture out of the system this year. Okay, it's kind of a let's see what we can learn. So if we grow these potatoes under less water, what's going to be the result of storage? I really can't tell, but I would expect there could be variety differences in the response that we see. And so maybe we'll learn that that some of the crop doesn't need as much moisture as we're putting on. But we can adjust this, how much rain out, how much water we're removing from the system or preventing the crop from getting, in future years. But this is kind of our effort. And so again, the potatoes are going to be harvested. We'll look at their production, and then we'll also put those potatoes into the storage, monitor them, just like we typically do on a monthly basis, and see what kind of, if there is that, whether that drought stress or the reduced water stress will affect what we see in long-term storage. Because the way I look at it here in Michigan is we need to be able to predictably grow our crop, and we also need to be predictably store our crop so that we can meet our market needs as we go on. So in addition to these studies, the breeding program is looking at other avenues to develop new varieties. And across the road there, we have some genetically engineered potatoes that have drought resistance. We've been studying those for a few years, and we're continuing to study those across the road. And I could see in the future that those might be candidate varieties for us to look at under the water stress conditions. What I haven't mentioned to the other groups is we actually also have our cold storing potatoes. So they're the potatoes that have the genetically engineered potatoes that have the invertase silencing. That's the same trait that Simplot put in their potatoes. We have that in our Kalkaska variety across the road, which seemed to be a variety that had good production characteristics and scab resistance. And we know that potato, the vent that we have, will store it, 40 degrees. And so we could actually consider that as a management system, as storing the potatoes colder to get to our, and still maintain the chip quality. And lastly, we have our diploid breeding program, which is kind of an aspect to bring in wild germplasm that has a lot of disease and insect resistance traits, but also has what we see is heat stress and water stress resistance in a lot of this diploid germplasm. And through that diploid breeding, we feel that we can more effectively bring those traits into the varieties. So whoever ends up replacing me as a breeder at Michigan State will probably carry on that work and hopefully get varieties of that from that new breeding approach. But we figure we have to lay the foundation for that right now. So that's kind of where we're at. We're trying, we kind of see this research as kind of as a benchmark, and we want to move forward from there. We want to work with our colleagues in Wisconsin and our colleagues in Idaho on a maybe more national level to deal with this climate resilience. So at that time, now I'll stop and take any questions or comments from people. Oh, okay.
Is there much breeding still going on in the country with modifying?
GM potatoes? Well, okay, so Tim's asking about GM potatoes. So Simplot is still working on that.
Oh, they are.
Yeah, they're still in that business, they want to come up with their third generation, and so they're building those potatoes right now. So what the changes in the USDA right now have made it so that like our potato, the Caucasica I'm talking about, potentially we can petition the USDA and say, well, our potato has the same trait as the Simplot potato, and it's just a different variety, and they can then make a decision that does not require regulation without going through the long review process. So what the regulatory government has said is that GM products that have been out and proven safe, just by putting it in a different variety, doesn't make it risky, and so they're giving a pass on those. They're still GM, but it's not having to go through the whole major review process that could take years and lots of money. So there is opportunities to build on the products that are out there. For example, like this Caucasica. So as long as the markets can bear the
Currently they won't, but
yeah. So, but great question.